we're actually going to simplify them today with the doing really the simplest ones using just numbers. A little bit of variables, but not too much. So the expression that contains a radical sign is a radical expression. There are many different types of radical expressions, but in this course you only study radical expressions that contain square roots. So here is an example of some radical expressions. The part underneath the radical sign is called the radicand, and it may contain numbers, variables, or both. It may contain one term or more than one term. So the simplest form of a square root expression or radical expression is the radicand has no perfect square factors other than 1. It has no fractions, and there are no square roots in any denominator. All right, so we can't leave square roots in the denominator. So remember that positive numbers have 2 square roots, one positive, one negative. However, just the radicand sign here indicates non-negative square roots. So when you simplify, be sure that your answer is not negative. To simplify the square root of x squared, you should write it as the absolute value of x, because you don't know whether x is positive or negative. All right. So simplifying square root expressions. So first of all, when you're trying to simplify expressions, we always want to simplify what's under the radical, what you can, first of all. Right? So in this first one, we have the square root of 2 over 50. So if I have a fraction, then I want to be able to, if I can simplify that fraction first, I want to do that. Right? So since 2 goes into both 2 and 50, I'm going to simplify this to the square root of 1 over 25, first of all. And then the square root of 1 is 1, and the square root of 25 is 5. So this is just 1/5. The square root of 8 squared plus 15 squared. The first thing we want to do is simplify what's underneath the radical. So we need to do 8 squared plus 15 squared before we find the square root of that. So 8 squared is 64, 15 squared is 225. So when we add them together, we get the square root of 289. All right, which your calculator will tell you is 17. Now expressions like letter C, that is a perfect square trinomial there, x squared minus 6x plus 9. So I'm going to factor that first. So it becomes the square root of x minus 3 squared. All right. And so when we undo something that's squared, all right, and like they had up here with the absolute value of x, this would be the absolute value of x minus 3. Because we don't know whether that would be positive or negative. Check out it's way down here. All right. So do these 4. Okay, so the next thing then is we're going to use the product property of square roots. Now before we do this, I want you to, you need to make a table. All right. So what I want you to do is make a table of squares. So from 1 squared all the way down to 15 squared. All right, now I would put this somewhere where you're going to find it easily. So maybe if you're using a spiral, then maybe it's going to be on the inside cover of your spiral, something like that. Or maybe a piece of notes or on your folder or somewhere where you can just turn to it and find it real quickly so that you can access it. Because knowing all of the squares up to 15, or at least having them available for you, is going to make this easier. Okay, so because what we're going to be doing is using squares to simplify radical expressions. So here we have the product property of square roots. It says that if I have, like the situation here, square root of 4 times 25, which is the square root of 100, is 10. Or what the product property says is that I can take the square root of 4 and the square root says the square root of 4 times 25, and I can pull that apart and say, well, okay, that's the square root of 4 times the square root of 25. And either way, I still get 10. But if we have the square root of a product, we can write that then as the product of those separate square roots. Right? So the square root of a times b is equal to the square root of a times the square root of b. Because when we say we're going to simplify a radical, we're not going to write it as a decimal. We're not just typing that in our calculator and getting some decimal number. We're actually going to write it using, you're still going to have radicals in your answer unless it's a perfect square. All right, so here we have the square root of 24. And we want to simplify this. All right. So what I'm doing then is I'm looking for the largest, to be able to simplify it, I'm looking for the largest square that goes into 24. All right. So if we think about the factors of 24, now there's a couple different ways we can do this, okay? One is if you know all your factors, you're good, all right? So I can look at the squares and say, okay, which of these, what's the biggest one of these that goes into 24? All right, and so well, we know that 4 times 6 is 24. Now if we think of it using our calculator, that when we were factoring before, when we were doing factors, we say, okay, let's do 24 divided by x, all right? Because I want to be able to factor something that has 24. Okay? And so if I look at the factors now, I say, okay, so when I look at the factors of 24, which ones give me the largest square that goes in them? So I know that 2 times 12 is 24, but neither 2 or 12 is a square, so I can't use them. 3 times 8 is 24, but neither 3 nor 8 is a square, so that doesn't help me either. I'm looking specifically for squares. And so since 4 is a square, and it's the biggest square that goes into 24, then I'm going to rewrite 24 as 4 times 6. So the square root of 4 times 6 then. Then I can use the product property, and I can pull them apart and say, okay, well that's the square root of 4 times the square root of 6. And then we know that the square root of 4 is 2, because 2 squared is 4. So then I can rewrite the square root of 4 as just 2, and this becomes 2 times the square root of 6, or 2 square roots of 6. So let's do, before we do the one with variables, let's do another one of these. Say the square root of 98. So I want to find the largest square that goes into 98. Okay? So I can look at, I could make a factor tree. Right? I don't want to do prime factorization. Prime factorization is one way we could do it, but I prefer to do this without doing the prime factorization. It's easier. So we want to find, okay, what's the largest square that goes into 98? So I can look at my list of squares over here, 1, 4, 9, 16, 25, 36, 49, 64. Okay? The one thing we know that we should always start with is does 2 go into that number? All right? Because sometimes it's just 2 times the square. Right? And so, does 2 go into 98? Yes, it does. Okay, because it's an even number, so it does. So 2 times 1 is 98. 49. All right? So, and 49 is a square. So I can rewrite this then as the square root of 49 times 2. Now I'm always going to write it so that the square goes first, okay, the number that's squared. Okay. So then I can use the product property, rewrite it as the square root of 49 times the square root of 2. And we know that the square root of 49 is 7, so this is 7 times the square root of 2. All right, and so we're looking for the largest square that goes in it. And so I could use my calculator here also. Change that 24 to a 98. All right, look at my table. All right, so I'm looking for the largest square. Well, for 98, it's either 2 times 49 or 7 times 14. All right? 7 times 14 doesn't have a square. And 49 is, all right? So whenever you get, if you're going down the list and you get a number that's more than half, okay, then you know it can't be that. Okay, so let's look at one where we've got variables. But we're always looking for the largest square. Okay, so here we're working with just variables as the square root of x cubed y to the 4th. And when we're working with variables, right, we're looking for even powers. All right, we always want to break them up into even powers. So if I have the square root of x squared, right, well, that's x. The square root of x to the 4th is x squared. Square root of x to the 6th is x cubed. So we always want to work with even exponents. So because when I take the square root of an even exponent, we're just cutting that in half then. Right? So square root of x squared x to the 4th x squared, x to the 6th would be x cubed. Okay? So here we have the square root of x cubed y to the 4th. So I'm going to pull this apart. First of all, write it so that the two letters, the two variables are separate. And whenever you have numbers and variables or two different variables, always pull them apart so that the numbers and the variables are separate. Okay. Now, we want to have it so that we have even powers. So since I have x cubed here, I'm going to rewrite that as x squared times x. And it'll always be, if you have an odd exponent, it's always going to be the even exponent that's one less than that, and then something to the first power. So if I had x to the 7th, I would write it as x to the 6th times x. Right? So I'm going to rewrite this then as, I'm going to pull the x cubed apart, and I'll make it x squared and x. Now we rewrote it here so that we would have the thing with that's still under the radical left on the end. Right? Now, square root of y to the 4th is y squared. Square root of x squared is x. So, and I don't have that one. Right? So the final answer here would be x, y squared, and then we have the square root of x left. So we just cut the power in half when we're working with variables. All right, you guys just do 2a here. Do 2a. Square root of 128. All right. So the thing to remember, always make sure that you've got the largest square that you're using. Whenever you've got variables, make sure you pull them apart, first of all, to start with. And if you got numbers and variables, then you're going to separate all of them to begin with. All right. Quotient property says that if I have the square root of a fraction, I can rewrite that as the square root of the numerator divided by the square root of the denominator. Right? Square root of a fraction is equal to the square root of the numerator divided by the square root of the denominator. But once again, just like we did in the first example, if I can simplify the fraction first, then I want to be able to do that. All right, so we've got two examples here, square root of 5/4 and the square root of m cubed over 9m. Square root of 5/4. So using the quotient property means then that I can rewrite this as the square root of 5 over the square root of 4. Now I look at both parts, all right? And with the ones that I have for you today, the denominator is usually going to be, that's going to be a perfect square. Right? So my denominator here is going to be 2, because the square root of 4 is 2. Right? Then it's just a matter of, can I simplify the numerator? Well, the square root of 5, okay, there's no squares that go into that, so this would be the square root of 5 over 2. So if we have a fraction, first thing we want to do is simplify the fraction if we can. Then we write it using the quotient property, which means the numerator and the denominator are two separate radicals. And then simplify those two parts as they are. So letter B, okay, we have m's in the numerator, m's in the denominator, right? Which means I can cancel them. All right? I can cross out 1m here. So this becomes the square root of m squared over 9 when I cross out, make that a 2 and cross that out, right? So we do some canceling. So then I use the quotient property. It says the square root of m squared over the square root of 9. So the numerator is m, the denominator is 3. Okay, but always the first step, number 1, simplify the fraction. Look to simplify the fraction. Lots of times when you're doing these, you can see it immediately. If you're looking at like B and C here, all right, I can see what those are. All right, you don't have to show me any work for that. You can just write the answer down. Okay, you don't need to write square root of 36 over square root of x to the 4th gives me 6 over x squared. Okay, if you can see it, which a lot of you can, then go ahead and do that. All right. Now this one, the letter A, yes, you need to show me at least the fact you went to 4/9, and then it's 2/3. So. Okay. All right. So now we're going to add a little bit, just change the numerator. That we're going to have a situation where we've got to work with the numerator. So let's Let me get rid of this mess here. Okay, so we have the square root of 108 over 25. So my first step is going to be to pull them apart. Oops. First step is pull them apart. So I'm going to write it as the square root of 108 over the square root of 25. I mean, that's because I know that I can't simplify 108 over 25. And sometimes, okay, sometimes you're going to be in a situation where you could simplify it, but it doesn't pay to start with. Because if your denominator is a perfect square, then don't simplify. Okay? In other words, if I had the square root of, let's just say this for the moment, square root of 125 over 25. All right. Now, I could simplify this first, but because the denominator is a perfect square, I might want to just do this, leave it like this, because when I simplify, the denominator is that whole number. Okay? Now, that's not necessarily a great example, but the point is that whenever I can, if I have a denominator that is a perfect square, I want to leave it that way whenever I can. Okay? So, square root of 25, we know that's 5. All right, we're just going to take care of that right away. But now we need to work with 108. So we need to find the largest square that goes into 108. All right, so let's see. I can't think of what it is. All right, so I can go down my list, 4, 9, 16, 25, 36. You know, I can't think of what it is. All right, so I'll go to my calculator. All right, 108 divided by x. Go to my table. All right, so here's my list. Go ahead and now when you do this, when you look at your list here, all right, all I need to look at is the numbers to where these are about the same, okay? Because the closer, once they get to be the same, then it's just going to go back and going to give me those same numbers again, right? Okay, it's just going to, the next thing I'm going to see is 12 and 9, all right? So let's look for the squares I can see here. So I look at the squares, here's a 36, here's 4, and I've got 9. So I have 3 different squares there I can work with, but I always want to work with the largest one. Because if I don't use the largest one, then I've got to keep going because I didn't finish it. So then I'm going to rewrite this as the square root of 36 times 3. Because 36 is the largest one of them. So, square root of 36, square root of 3 over 5. So 6 square roots of 3 over 5. And once in a while you may end up in a situation where your 6 and your 5 here, those have a common factor also that you could simplify that part of the fraction. Right? But the one thing is make sure when you write your answer, all right, you have 2 options. All right? You can write it like this, which is what I would suggest. Or you could actually write 6/5, where the square root of 3 is basically in the middle. Okay? You can't write it in the denominator, but you could leave it like that. Right? But like I said, my suggestion is just leave it like this then. Okay. All right? So just be careful when you're looking at the ones on your calculator that you're looking for the largest square, not just a square. Okay? It's got to always be the largest one. Okay. I think we're good.